Hi everyone. Today's lesson is going to be on force and gravity and how it relates to vectors. So a lot of the things we're going to be doing are similar to the last couple days, and then there's one final topic on Monday, which is work, which has to do with projection of vectors and what we do today as well. So we're almost done with the chapter. Before we get into an example problem, I wanted to kind of give you kind of a foundation conceptual kind of idea of like what's going on here. So what I have here in this diagram up here is force and gravity is the general topic. Imagine this circle in all these diagrams is a bowling ball. And your job is to kind of keep this bowling ball in place. So basically don't let it roll down the hill. If you have a straight horizontal line like this, holding the bowling ball in place is super easy. In fact, you don't even need to do anything. You don't need to exert any force onto this bowling ball in order to keep it from rolling down the hill. Now imagine if you had a slight incline, like this one is. In order to stop this ball from rolling in this direction, you would have to hold it back a little bit, but you wouldn't have to use a ton of force. You kind of just rest your hand on it, use a little bit of force to make sure it doesn't roll down. As this hill gets steeper, gravity starts having a bigger impact on it, because the angle is sharper. So you would need to have more force holding the ball in this direction so that it doesn't go in that direction. And then finally, imagine if it was just a free fall. So if you're just trying to hold a bowling ball in the air, that would require a direct force. Whatever this force is going in this direction, let's say this is a 15-pound bowling ball, you would have to have 15 pounds of force going in this direction. Okay, so now going backwards. 15-pound bowling ball, 15 pounds of force going in the opposite direction. If this were a 15-pound bowling ball here, gravity would be going straight south, but all 15 pounds wouldn't be associated with the direction the ball is going in. Only part of it would be. A bigger part than over here, but still smaller than over here. So if you can understand the general concept that as a ramp gets steeper, gravity has a larger impact on it, and it's harder to prevent things from rolling down a hill. That is the important thing to kind of understand as we go forward. Okay, so now for the kind of problems you're going to be seeing. There are going to be problems like this where you have some kind of angle here, let's call it 25 degrees in this case, and you're going to be holding this car here. And what you want to do is try to hold the car so that it doesn't roll down the hill. And the question is going to be, how much force do you need? Well, there are two things that you need to know. You need to know the overall weight of the car. Let's say the car is 1,000 pounds. You also need to know the angle of 25 degrees, so you know the amount to which gravity has an impact on it. The way these problems are always going to work is you're going to draw a line straight down from the car, or whatever object you're doing. That line straight down is going to be, in this case, 1,000 pounds. The effect due to gravity that exists when you go straight down. The next part of it is going to be drawing a perpendicular to the ramp. And there are two things happening here. There's this component and this component. These are the two components which kind of make up that 1,000 pounds. It's distributed between the ramp and then the perpendicular to the ramp. So the force that is actually happening, the force the car is exerting, is going in this direction along the ramp. So this is the force vector for the car. Because that's the force vector for the car, in order to stop it from rolling, you would have to have an equal force going in the opposite direction to keep it from rolling down the hill. So when we make these diagrams, and the question is going to be, how much force do you need in order to stop it from rolling? It's going to be this line up here, which directly counters the car moving downhill. Okay, let's move on to an actual problem now. This is example 1 from the worksheet in Schoology. A couple of notes up here kind of summarizing what I said earlier on in the video. So A 2,000-pound car is on a ramp with a 15-degree angle of elevation. How many pounds of force would it need to keep it from rolling down the ramp? Let's make a visual. 15 degrees. Here's my car again. And the gravity force, the 2,000 pounds, is going to go straight down like this. So if this car is just free falling, it would have 2,000 pounds of force going straight down. It is not free falling, it's going in this direction, so it's going to be something less than 2,000 as far as the actual force that's going in this direction. In order to find out what that force is, we are going to draw a perpendicular to the ramp. An orthogonal vector, you can think of it as. You could think of it as a normal line, it's called sometimes. Make a right angle with that ramp. This car's vector of its force is this right here. So if you were holding this over here, you'd want to know the force needed to balance it out. Fortunately, it's a super easy problem from this point, as long as you can understand that this is what you're looking for. If this is 15 degrees, that makes a right angle there. This angle's in both triangles. In the end, this angle over here is also going to be 15 degrees. And this is always going to be true with these diagrams, that this angle and this angle always end up being the same. So if this angle is 15 degrees, and we want to find out what this length is, it's just a sine problem. Sine of 15 is equal to the force vector that we need to hold it back, divided by 2,000, the hypotenuse, or the weight of the car that is being impacted by gravity. So then it becomes 2,000 times sine 15, and we throw it in the calculator. And it looks like we get 517.64. So that is the amount of pounds of force you would need in order to keep this car from rolling down the hill. Hopefully you understood that. Hopefully you also understand the general idea that if this had been at a much steeper incline like this, it would have been much harder to hold this car back. And this triangle would have made this opposite side of that angle much larger, so this would have been a bigger number if the weight of the car had been 2,000 pounds still. So in the end, as long as you can make this diagram and use some basic trigonometry to get the answer, you should be able to answer the remaining 3 questions for today's assignment. If you want to get ahead, you can look up work and try those problems that are assigned on Schoology for Monday. Otherwise, have a nice weekend and send me any questions. Talk to you soon.